Okay, so now that we've finished studying square roots, we're going to look at a couple of different geometry applications that allow you to practice this skill of simplifying square roots a little bit further. So in this first lesson, we're going to talk about a very special property concerning right triangles called the Pythagorean Theorem. So first and foremost, what is the Pythagorean Theorem? The Pythagorean Theorem discusses only right triangles. So if you don't know what a right triangle is, right triangles are triangles that contain a right angle. So they contain a 90-degree angle for one of those angles in the triangle. So a right triangle contains one 90-degree angle, hence the name. Now, in a right triangle, there are special names for the different side lengths. The side length that is across from the 90-degree angle is called the hypotenuse. And this will always be the longest side length of your triangle. So if you have a right triangle, your longest side length will always be across from that 90-degree angle, and it will be called the hypotenuse. Now, these other two side lengths, so I have them labeled A and B. These non-hypotenuse side lengths are called legs. And when we have a right triangle, the very special property concerning the right triangle relates the side lengths of the triangle. And you can see that right here. It says a squared plus b squared equals c squared. And this special relationship concerning these side lengths basically states that the hypotenuse squared is equal to the two legs squared and added together. So this is, again, only true for right triangles and is called the Pythagorean Theorem. And it allows us to find a missing side length if we happen to know two of the side lengths of a right triangle. So we'll be using this property as we move forward. And again, this Pythagorean theorem is true for all right triangles and allows us to find a missing side length of a triangle. Okay, so now we're going to jump right in and we're going to apply this. And remember, the Pythagorean theorem is a squared plus b squared is equal to c squared, where c is what's called our hypotenuse. So remembering that our hypotenuse squared, or our longest leg squared, is equal to the other two side lengths squared and added together. So we're going to use that Pythagorean theorem on each of these triangles listed. You can see here we need to identify the legs and the hypotenuse. So here, this y value, that's my c value, that's my hypotenuse because it is across from the 90-degree angle. My b value is 6, and my a value is 5. And if you had b and a switched around, you had b was 5 and a was 6, that's okay. The big important part is that you're labeling your hypotenuse as c. So here, if we now apply the formula, we have 5 squared plus 6 squared. So our two side lengths squared and added together that are not the hypotenuse are equal to the hypotenuse, which is y squared. So from here, if I start this problem, I have 25 plus 36 is equal to y squared. 25 plus 36 is 61. And then I know that to undo the squared, I need to use the square root function. And here, because I'm talking about side lengths, I don't have to include the negative square root of 61. I just need to include the positive because a length, or a side length of a figure, will always be positive. So here, I know that my side length is the square root of 61. And if I think before, when I was simplifying square roots, if I think about 61 and I try and divide 61 by all of the perfect squares that are less than 61, I find that 61 is actually in simplest form. So my value for y is the square root of 61. Now some of you might be asking why I left it in square root form rather than in decimal form, where I would basically find the decimal number. And that's because if you read the instructions carefully, it says to leave it in simplest radical form. So whenever you see that word radical, radical is essentially saying square root form. So if it's saying to leave it in simplest radical form, it's asking you to simplify your answer, as in you're simplifying the square root. Now if we look at number 2, again we need to identify our a, b, and c values. Our C value is across from the right triangle, so I know that 8 is C, and then I can label the other two however I want. I'm going to say A is B, or A is 4, excuse me, and B is X. So now if I use my formula, I have A squared plus B squared equals C squared, so I have 4 squared plus X squared is equal to the hypotenuse of 8 squared. 4 squared is 16. X squared stays the same, is equal to 64. Subtract 16 from each side. X squared is equal to 48. Again, to undo the squared, I square root each side. I then know that I don't need to account for the negative version of the square root of 48 because I'm looking at side lengths. So I need that to be positive. So x equals the square root of 48. And then from here, again, I need to make sure that I'm writing my answer in simplest radical form. So from here, I think, well, is 48 divisible by any perfect squares? The largest perfect square that divides into 48 is 16, because that's 16 times 3. So x is actually equal to 4 square roots of 3, and that is my answer in simplest radical form. And if I were to take this answer and plug it back into the triangle and use the Pythagorean theorem, it would in fact make the Pythagorean theorem true. Alright, so now looking at word problems, you can use the Pythagorean theorem on a variety of word problems, assuming that your word problem involves a right triangle picture. So here, if we read the instructions, it says, you have a ladder that is 21 feet long. You need to clean out your rain gutters, which are 15 feet off the ground. How far away from the building must you set your ladder in order for it to reach the top of the building? So if I think about this situation here, I have a building. So there's my building. And I have a ladder that is leaning up against the building. I'm going to draw that a little bit cleaner there. I have a ladder leaning up against the building right here. So what this picture is telling me is that I have a ladder that is 21 feet long. I also know that my rain gutters are 15 feet off the ground. So they are 15 feet straight up in the air. So I've leaned my ladder at an angle because I want my ladder to be stable, and it's going 15 feet up the ground. And this particular question is asking me how far away from the building I should set my ladder in order to reach the building. So it's asking me to find this distance right here in green. Now, if you look at this picture, you can see that the building and the ground form a right angle with each other. So this does in fact involve a right triangle. Now I'm looking for this value here, x, which is the ground level. So now I know that I can apply the Pythagorean theorem. I know that my value for C is 21, my value for B is 15, and my value for A is x. So now if I apply my Pythagorean theorem, I have a squared, which is x squared, plus b squared, which is 15 squared, is equal to c squared, which is 21 squared. Alright, so now from here I can start to solve. Now I have x squared is still x squared, plus 225 is equal to 21 squared, which is 441. So now if I subtract 225 from each side, I'm going to jump up here, I get x squared is equal to 216. I know to undo the squared, I need to square root both sides, and I don't need to account for the negative version of the square root of 216 because I want a positive length. I then have x is equal to the square root of 216. Then if I look at my perfect squares and I experiment enough, I will find that I can break 216 into the square root of 36 times the square root of 6. I then know the square root of 36 can be rewritten as 6. So my distance is 6 square roots of 6. That's the simplified square root form. However, if you read carefully, the instructions don't actually state how we need to leave our answer. So what you could do from here is if it did state, to the nearest tenth or to the nearest whatever, you could multiply that into your calculator and you could say this is approximately 14.69 feet long from the edge of the ladder to the building. So you would want to set your ladder about 14.69 feet away from the building if you wanted your ladder to line up perfectly with that building that is 15 feet up to the roof gutters. So as you start to do your own word problems, make sure that you draw a picture. That picture will save you as you try to identify if the Pythagorean theorem applies and which value would be A, B, and C. Alright, finally, you will be asked to solve slightly more complicated triangles like the one you see in front of you here. So you can see here that we need to find the value for x, and then we can use the value for x to find the different side lengths of this triangle. Now, the Pythagorean theorem applies in the exact same way here, so we're going to identify our a, b, and c values first. So c is across from my 90-degree angle. There's a. And there is b. So over here on the left-hand side, I'm going to write this out. I have a squared, which is 2x all squared, plus b squared, which is x plus 1 quantity squared, is equal to c squared, which is x plus 3 quantity squared. Now from here, I'm going to simplify these each one at a time. I know 2x squared is really 2x times 2x, which then if I combined the correct terms, I have 2 times 2, which is 4, and x times x, which is x squared. Then if I look at x plus 1 squared, I know that that's a binomial times a binomial, so I know that I can multiply that out using the box because of that plus sign in there. So I then have x squared, 1x, and 1 times 1 is 1. So this would simplify to be x squared plus 2x plus 1. And then if I look finally at that last piece, I have x plus 3 quantity squared. So x times x is x squared, 3x, and 9. So this would be x squared plus 6x plus 9. So now if I rewrite that statement up in red, again down below, with all the squareds multiplied out, I get 4x squared plus x squared plus 2x plus 1 is equal to x squared plus 6x plus 9. Now with all the squareds in there, I think that this is going to be a quadratic problem, but I won't actually know that until I get all of the correct terms, or all the same terms, on the same side of the equation. So I'm going to subtract x squared, subtract 6x, subtract 9. So subtract x squared, subtract 6x, subtract 9 from each side. I then end up with, so that would have been 5x squared minus 1x squared, which is 4x squared, 2x minus 6x, which is minus 4x, a positive 1, and then that's a subtraction of 9, so that's minus 8, is all equal to 0. And here I can see this is in fact a quadratic, so I'm either going to have to use factoring or the quadratic formula. And just to remind you, if you do choose to use the quadratic formula, x equals negative b plus or minus the square root b squared minus 4ac all over 2a. And that's what I'm going to choose to use here. So if I actually plug this in, I get x is equal to a negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And then if I begin to simplify this further, a negative 4 is a positive 4, plus or minus the square root. If I plug that into my calculator and carefully use parentheses, I will get 144 underneath my square root, and then all divided by 2 times 4, which is 8. So now if I kind of break this down a little bit further, I get 4 plus or minus the square root of 144 is 12, then all divided by 8. So now if I split this up, 4 plus 12, then divided by 8, and then I have 4 minus 12 divided by 8. 4 plus 12 is 16. 16 divided by 8 is equal to 2, so there's one potential x value. And the other x value, 4 minus 12 is negative 8 divided by 8, which is negative 1. So I have two potential values for x here. X could either be 2 or x could be negative 1, or maybe they both work. Now if we take both of these values and we actually look back up here we know that we have the potential that x is equal to 2 or negative 1. We see that. But if we realistically start plugging these in, if x is equal to 2, my side lengths would be a is equal to 2 times 2, which is 4. B is equal to x plus 1 or 2 plus 1, which is 3. And C is equal to x plus 3 or 2 plus 3, which is 5. On the other hand, if x is equal to negative 1, okay, A would equal to negative 1 times 2, which is negative 2. B side length would be negative 1 plus 1, which is 0. And C would be negative 1 plus 3, which is 2. For side lengths, that really doesn't make sense. So the one value for x that we would use in this case for the side lengths of a triangle would be x equals 2 because it produces all positive side lengths. All right, and finally, we are going to actually use the Pythagorean theorem in reverse. So we're going to try and use the Pythagorean theorem to prove whether or not a triangle is in fact a right triangle. So here you see a picture in front of you. We're trying to decide if this is a right triangle. So basically what we're going to do is we're going to say if the Pythagorean theorem works with the three side lengths that we see. If the Pythagorean theorem works, then this is in fact a right triangle. Because if the Pythagorean theorem works, well, the Pythagorean theorem works for all right triangles and only right triangles. If it works, then we definitely have a right triangle. So here, if I look at my three side lengths, I see 8, 15, and 17. I know that the hypotenuse has to be the longest side. Remember that. So my hypotenuse has to be 17, which then means that that is my C value. So what I'm assuming is that 8 is A, B is 15, and C is 17, which is my hypotenuse or my longest side length. So let's test this out. If the Pythagorean theorem works, so I'm saying, okay, I'm questionable. I'm not sure if this is going to work. But if the Pythagorean theorem works, then this is a right triangle. So 8 squared is 64, 15 squared is 225, 17 squared is 289. So I'm testing to see if this does work. 64 plus 225 is in fact 289. And because this is true, because the Pythagorean theorem works, we can state, yes, this is a right triangle. We can state that the side lengths of 17, 8, and 15, those three side lengths will in fact make a right triangle. So on the next slide, what you're going to do is you're going to use the Pythagorean theorem to prove whether or not a set of side lengths will create a right triangle or will not create a right triangle. All right, so here it says, use the converse of the Pythagorean theorem to determine if the following triangle side lengths form a right triangle. So basically we're saying, use the Pythagorean theorem to prove whether or not these will make a right triangle. So first thing I look at in number 1 is I need to identify my hypotenuse. My hypotenuse is always my longest side length. So that means that 9 must be my C value or my hypotenuse. Then I can say, okay, 5 is A and B is 8. So I have A squared, which is 5 squared, plus B squared, which is 8 squared, is equal to C squared, or my longest side length squared, which is 9 squared. So I'm checking to see if that works. Here I get 25 plus 64 is equal to 81. Still checking to see if this works. 25 plus 64 gives me 89. The right-hand side is 81. And because this is a false statement, because this does not work, I would state that the triangle side lengths of 5, 8, and 9, no, do not form. So this is not a right triangle. And it's simply because the Pythagorean theorem does not work with the side lengths. Now if I flip gears and look at number 2, again, my hypotenuse is always my longest side length, which in this case is 15. Then I'm going to say my A value is 9 and my B value is 12. So here if I start, okay, A squared is 9 squared plus B squared is 12 squared is equal to C squared, which is my longest side length, which is 15 squared. Checking to see if that in fact works. 9 squared is 81, 12 squared is 144, which would be equal to potentially 225. Well, if I do 81 plus 144, I find that I get 225 is equal to 225. And then I can see that this is a true statement that the Pythagorean theorem does in fact work. So yes, these side lengths do in fact form a right triangle.